Hello and welcome to the episode 5, where we're gonna learn to use the basic standard Golang library packages, standard image packages of Go. And so what we plan to do now is to do this Lisaju figures. So let me show you what it looks like. Okay, it looks like this, and then we are supposed to create an animated GIF of this. So I never went so far into the book, so we're gonna discover by together what exactly it is. It looks like a little bit like this oscilloscopes figure you can have. And they say the image called Lisaju figures were a staple visual effect on sci-fi films of the 60s. I was not born, so I don't know what it is or which kind of movie they refer to. But they're the parametric curves produced by harmonic oscillation in two dimensions, such as two sine waves fed into the x and y inputs of an oscilloscope. Alright, and then that's the same, they just give an example right away. So Visual Studio, let's do this. They're importing many more packages on this one. Tutorial. We're still in the chapter 1. I should clean this folder, by the way. But anyway, they call that Lisajus. Oh, of course. .go. Alright. Package main, because it's a program. Import. I can show you all the imports they have. Image, image color, image GIF, IO, input output, math rand. It's probably gonna have some random here. OS. Oh, of course. I don't choose them so it disappear. Let's go just take a look. Golang doc image. Package image implement a basic 2D image library. The fundamental interface is called image. An image constant colors which are described in the image color package. Alright. So that's why we also have then the color package. GIF value containing image data in a format such GIF. Okay. IO is input output, math rand, so it's a math package, math rand is to have like random probably somewhere, and OS is probably for the arguments. So let's copy all of that. Wow, that's long. So we have a palette. So this is a global variable, color, and then color.white. Color.black. So here we probably have only two colors. Our palette is written this way. And we also have a constant white index equals 0. First color in palette. Palette has only one hell. Black index equal 1. Next color in palette. Alright. Func main. So this time the func main gonna be really small because it's only that's weird. Std out. Okay, we will see later why. And then on top of that you have the function Lisaju, which is called in the main. Let's take IO writer. Some const variable here. Cycles 5. Number of complete X oscillator revolutions. I have no idea what is that. I'm not that good with math. angular resolution. Okay, size 100, image canvas cover minus size plus size. Once again, I don't know what it is. End frame 64. Number of animation frames. So to generate a GIF, you need to have like certain amount of frames, so image. And here it says that we're gonna make a GIF with 64 images, from what I understood. Delay between frames in 10 ms units. So between every picture or frame we are gonna probably have a delay of 10 milliseconds before going to the next one. So frec rand float. So that's we're going to have a random here. Float 64. Relative frequency of y oscillator. I think we're gonna have to play with the number to check what it does because I have no clue here. And then we use the GIF function, the GIF package and GIF function of this package, loop count and frames. Phase, I don't know where's that. Phase difference, alright, for E go inside the loop, initialization of E is smaller than end frames, E++, so that's probably where we're gonna generate the GIF. Rect image rect 0, 0, 2 for 2 times size plus 1, 2 times size plus 1, so probably the width and the height. Let's check that. Should I just say after? Image new palette set rect palette for t, another initialization of t here. Then the condition is t cycles times 2 times maths.p, right? T plus equals, oh my god, I have no clue what I'm doing right now. Math sin for sinus maybe, probably. Rec plus phase img set color index size plus int. So we change the type of the float, probably it's a float, yeah. Size plus, oh no, it's just to round up this value properly. Size plus int y size plus 0.5. Okay, and black index. Wow, we are done with this. What is the mistake here? Cycles, unexpected math, expecting semicolon on new line. There's a semicolon here. Cycles times 2. Okay, better. Phase plus equal 1. Anim delay. Append anim delay. Delay. Anim image. Append anim image. Image. Then we encode it. Encode all out address of anim, and we are not checking the case. Wow! I'm gonna try to compile it first. Okay. O lisse ajout de doigt. Okay, so just print for now the GIF. So I guess it's to redirect it to file. So I redirect the standard input inside file.gif, and then I'm gonna open file.gif. Okay, maybe I should use preview for that. And then here it is. We have the GIF. Okay. So this exercise looks to be like really math, a lot of math inside, and I don't know what they try to teach to us here, except that there is a package that's allowed to do manipulation on images. So let's try to reduce the delay to see if it's faster. I should compile it. So, all right, it's faster. So the delay is how many milliseconds you're gonna wait between two pictures or frames. If we increase the frame, do we have something more smooth? Let's check. Smoother. Okay. I'm not sure about the smoothness. Okay, let's put back the first value. Size image canvas cover, so probably the size of the image. So that's mostly how I learn things. I'm trying to change the value and I see the impact it has on it. So yeah, we can see the picture is bigger now. Angular resolution. Let's try something way bigger. Okay. I don't know what it does. I'm trying to increase a lot. Oh, the file is way bigger. And I don't see difference here. Okay. Angular resolution, I don't know exactly what it is. And second, number of complete X oscillator revolution. So if I change it by 1. I have no clue. Okay. Round float, relative frequency of Y oscillator. 5. Okay. Okay. GIF loop count phase. So we enter inside a loop, and while end frame is smaller than while E is smaller than end frames, so we create an image with the colors given, and here I don't know, we probably create the oscillation here, because I see we use sinus, and we put the colors, and then what phase is doing? I don't know. anim delay. Then we append inside anim. So anim is probably a no, it cannot be as, yeah, it's probably like a slice of something. Delay is a slice of int. An image is a slice of image paletted. So we have used image paletted somewhere here. So of course that's why. And we put the rectangle side and the palette. Okay. So what they want to say here, after importing a package whose path has multiple components, like image color, we prefer to the package with a name that comes from the last component. Color.white belongs to the image color package. GIF.GIF belongs to the image GIF. Okay. A const declaration. So as you can see, we have created constant variable here. Constant is something that is not you cannot change during the execution. So cycles is 5. I compile it. It won't change, and the code cannot like change its value. I think from memory, constant variable is not stored at the same place in the memory, but that's really something I'm not sure. And it makes the variable faster to be accessed. So that's why when you have a constant and you know the value won't change, it's probably better to declare it as a constant variable. Like var declaration, constant declaration may appear at package level, so the name are visible throughout the package age or within a function. The expression color.color and gif.gif are composite literals, a compact notation for instantiating any Go composite type from a sequence of element value. Here is the first one, a slice. The type gif.gif is a struct type. So maybe I can show you here what it looks like. So that's what a structure looks like. So a structure is a bunch of variable inside just one, so you can access it like quite easier, and it makes the code more clear. So type GIF is a struct. Inside this struct you have an image paletted, you have a slice of int, which is a delay, a loop count, disposal, and then your whole function can use it and access what it needs to do something. How they say that? Is a struct type. A struct type is a group of value called fields, often of different type, that are collected together in a single object that can be treated as a unit. The variable anim is a struct of type gif. The struct literal creates a struct value whose loop count field is set to n frames. All of the fields have 0 value for the type. The individual field of struct can be accessed using dot notation. So yeah, you can access then, for example, here, I can access the value, here, I can access the value of loop count by just doing anim.loopCount, for example. And that's what we are doing later on. In anim, we set the value of delay, and we append because it's a slice, and we set the value of image, and we append because it's also a slice. So that's how it works. And the ListAjout function has two nested loops. The outer loop runs for 64 iterations, producing a single frame of the animation. It creates a new 201 image with a palette of two colors, white and black. All pixels are initially set to the palette 0 value. Blah blah blah. The inner loop runs the two oscillators. The X oscillator is just the scene function. So that's what I said. And they explain how to compile it and how to forward the standard output to a file, but I already showed you that with the we call that chevron. I don't know the English name for that, but with these characters. So when I do ListAjout, it's printed inside the standard output, and then I put the content of the output, I forward it to a file. So now they go straight to exercise. So I think it's gonna be hard for me because I don't really know what's happening. Change the ListAjout programs color palette to green on black for added authenticity to create the web color RRGGBB. Use color .rgba, and then they give hexadecimal, so .xrr. I will have to find this, and the transparency at the last. Well, anyway, where each pair of hexadecimal digit represent the intensity green, red, green, R for red, G for green, B for blue, and the last one is the last value is the transparency, I think. But let's check it later. Okay, exercise 1.5 and the 1.6. 1.6, modify the Lisajou program to produce images in multiple colors by adding more values to palette and then displaying them by changing the third arguments of set color index in some interesting way. Okay, let's do that. Okay, I wrote this like really badly probably, but anyway. Change the Lisajou color palette to green on black for added authenticity. To create the web color, use color RGBA, where each pair of hexadecimal digits represents the intensity red-green. Okay, so the palette is here, and instead of using color white, we have to come up with RGBA. So from what I understood, the first argument here is the background, and the second one is color RGBA, and RA, the last argument is the alpha, so transparency. So let's try this. So we have to have a black background and the colors is supposed to be green here. Let's first try this, if it exists or not. Color black. Okay, color green seems not to be. Yeah, it doesn't exist. Okay, that's why you have to come up with RGBA. So they ask for a black background, so I think black exists so we can use it. And they ask for then a green color. So now we have to use this RGBA function they not mentioned. So color picker. So Google come up with this, which is quite good, and you have the value here for RGB. And I need to have a black one. No, green, sorry. So let's go with green. I'm not sure it will work this way, but let's try this. And then RGBA, what does it take? RGBA, it's supposed to be uint. So let's try this. Lisajou, this, and then 1. Alpha is 1. Not sure about this, let's check. Okay, Lisajou fine. And now we have what they ask. Black background and green green oscillation. So change color. So I think we're good. So what they were showing here on the example in the question, it's 0x and something, 0x and green, and 0x of blue, and 0x of alpha. So it's probably the hexadecimal version of it. So we can just try with the hexadecimal value. So for example here, hexadecimal value is 43 AD 11. So 0x 43, 0x 11, no, AD, 0x 11, and then 0x FF, maybe? Not sure. Let's try this. And then go build, s'ajoute. So yeah, that's exactly the same. So if I want to just check it works this way, let's put CC, CC, CC. So now it's supposed to be green, gray, from what I remember. Yeah, well, it's a white gray. It's not. That's doesn't look that gray. Check this. Can I change here? Yeah, it's a kind of gray, but yeah, light gray. Let's say that. So next question. So this one we can consider it's done. Okay. Modify the lissajou program to produce images in multiple colors by adding more values to palette and then displaying them by changing the third argument set color index. By changing the third argument of what? Of what, of course. So yeah, I should add more colors. So let's say I add green now. GBA 0x41. What was it? 0x AD, 0x11, 0x. I'm not sure about this. And then where do I use palette? I use palette here. So probably can take another argument. No, not here then. Set color index, this one. Image set color index, and they say index the third argument. I think X size. And black index is 1. I'm totally lost here. So gray index is 1 now. Green index is 2. Okay. Then let's try this just to check what it does. So I'm using only this color now. So if So modify the lissage program to produce images in multiple colors by adding more values to palette and then displaying them by changing the third argument. Mm. Okay. Guess we can just loop on this. Mm. Cheers. So for each frame I should change. So what I should do is maybe try this, and then it will loop on the 3 colors I have here. Sadly, it will also loop on the black one. Cannot use palette E type color as type, obviously. I need to give an index, so just maybe cannot use type int as a int date. I'll probably do that. Int. I don't know what it does. So yeah, we change the color. We loop inside the palette we have. So if I add more colors, I would probably be able to do this. Let's add a red one now. Do we have a red? No. Yeah, GEA. So red is probably FF 00 0x00 0xFF. I'm not sure about this either. So yeah, I think we succeed to do what they wanted us to do. I don't see the point of this chapter, to be honest. Maybe just to say that there is a package to create image and you can then create a GIF. Also to show maybe the struct, even if they don't go so much into the details of the struct, but you see in at least one, maybe some. Also the constant. But yeah, I'm a bit confused with this chapter, and if I read it, it doesn't really say anything interesting. So yeah, I think the first chapter was way better than this one, and it's maybe because there is a lot of math, so I'm a bit confused and don't really understand what's going on here. But yeah, I don't see what you learn. Well, you can put a loop inside a loop, maybe. It's something they wanted to show. The appends, it pushes you to a little bit take a look to what exists. So for example, append is to append the data inside a slice. So if you have a slice, let's say slice, my slice, it's a string. Let's say you have this, so there is nothing inside. If you do append into my slice, say 1, then now it's string, it's a string, so let's put ABC. So now my slice looks like this, ABC. Then if you put again append DEF, now your slice looks like this, and go on. So you've seen append, you have seen that there is a math package and you can use it to make sinus. Well, that's all for the video. I don't see the point, but if you discover something with it, and you, as a new developer in Golang, in your journey, you think this was really interesting, and I would be really curious to hear why. Um, Also, there is like this global variable, so it's not inside a function, meaning that palette can be accessed by all the functions in this file. But that's all. So thank you for watching. Let's go now for the next episode where we're gonna learn how to fetch new URL. Thanks for watching. Have a nice day. Bye bye.